This week we're going to do a 3-component mixture, and we're going to separate sodium chloride from cholesterol and ethyl 4-aminobenzoate. So we're going to use a SEP funnel again this week, and we're going to play the like dissolves like game again. So these 3 components this time are going to have 3 different chemical solubilities. So we already know that sodium chloride will dissolve in water, but cholesterol and ethyl 4-aminobenzoate will not. So we're going to use that property for our first separation. So what we're going to do is this sample is going to start off as a solid, and it'll be a known weight. And we're going to add water to it, as well as ether. And this is diethyl ether. So we're going to put them into the SEP funnel. So all of that together is going to go into our SEP funnel. So we know from last week that our separation in our SEP funnel is based on density. So we're going to have 2 different layers. And our solutions are not going to be green and blue, but we're going to do it just so that we can see it a little more clearly. So our samples, or our components, are now in these 2 different phases. So remember the property that we need to determine which layer is on the bottom and which layer is on the top is going to be the density. So if I look at the density of water, it will be about 1.0. And if I look for the density of ether, it's somewhere around 0.78 grams per milliliter. So that means my ether layer is going to be on top and my water layer is going to be on the bottom. And of course, we need to keep in mind where our compounds are going to be so that we correctly separate them. So I'm going to now have to decide where my sample is. So I've got cholesterol, sodium chloride, ethyl aminobenzoate. So one of the clues is that cholesterol and ethyl aminobenzoate are both, those organic compounds are going to be organic soluble. So our ether layer is going to have both the cholesterol and the ethyl aminobenzoate. So we learned last week that we're going to use that SEP funnel to separate them. And so we'll be able to drain off the bottom. And when we drain off the bottom, that's going to be our sodium chloride. And so now into our little Erlenmeyer flask, we're going to weigh our Erlenmeyer flask before we start. So in here is going to be a mixture of sodium chloride and water. Then we're just going to put this on a hot plate. We'll drive off all the water and we'll be left with sodium chloride. So that's a relatively simple one. So we're just going to rely on the solubility of water in, or sodium chloride in water. So now the other separation is going to be a little bit more challenging because now we're going to have a mixture of cholesterol and ethyl amino benzoate. So we're going to need our SEP funnel. So after we've drained out our SEP funnel, we'll have just the ether layer left in there. And now I need to rely on some physical properties of cholesterol and the ethyl amino benzoate. So cholesterol is a neutral organic compound, and it really doesn't have very many functional groups in it. It has an alcohol, but it doesn't have any functional groups that can act like an acid or a base. But ethyl amino benzoate, on the other hand, does. So if we look at our ethyl amino benzoate, we see this amine group right here. So this amine has the ability to be protonated. So if I add HCl to this, I actually will get a protonated amine. And when I change the charge on an organic compound, I make it much more soluble. So when I turn this into a protonated amine, nothing else will happen to the rest of the 4-amino benzoate. Sorry, I'm running out of room up there. I'm going to make a really, really long carbon bond. Okay. So I've got my protonated amine. And so now this is going to be soluble in water. So the neutral one is not soluble. This is ether soluble. But the protonated one is now water soluble. So if I add HCl to this, it will be obviously in water. And I shake that up. I'm going to get a separation. That's going to this time look like my water is going to be on the bottom, but this time it's going to be acidic. So it's going to be an HCl. And I'll still have my ether up above. So now we need to ask ourselves, where is going the protonated version of the ethyl 4-amino benzoate? Where is that group going to be? So that's going to be down here in the water layer. So my protonated so this is now my amino version of it, etc., is in the water layer because now it's charged. And my cholesterol is now left in my ether layer. So now I have a good chance to separate those two. So my water layer, I'm going to drain that into a beaker. And my cholesterol, I'm going to drain that into a round bottom. So I can either put that on the rotovap, or I can just use a stream of nitrogen. And then I can get the mass of my cholesterol. So my protonated ethyl 4-aminobenzoate right now is in water, and it's not going to come out until I change the charge on that amino group from the protonated amine back to the neutral amine. So since I added HCl to make it protonated, I'm going to need a base to remove that hydrogen. So the base we're going to use is 6 molar NaOH. And what will happen is my 6 molar NaOH will actually change and deprotonate that amine, and you will go back to the neutral amine, the rest of my structure. And now this is not soluble in water. You're going to do what we call filter, and we're going to use a vacuum filtration. And the vacuum filtration will you'll put in the top, you'll put in a solid and a liquid, and the solid will stay on the paper up above, and all the liquid will get filtered through, and your neutral ethyl 4-aminobenzoate will be the solid in your filter. Then you're going to weigh that. So there's definitely some challenges to doing this lab. But if we can very carefully keep track of where we are, keep track of whether you're talking about the ether layer or the water layer, and you're going to, of course, label, label, label. Every container that you have has to be labeled. So there are no colors in this lab. So the sodium chloride is a white crystal, the cholesterol is a white crystal, and the aminobenzoate is a white crystal. So you won't be able to use your eyes to determine what compound you might be looking at. So we're going to continue doing this discussion and this technique for several more times in this semester. So this is a good opportunity to practice doing this extraction using a SEP funnel.